Hi again, everyone. This is example 3 from MAT 201 Calculus class notes, section 1.1, functions and their graphs. And this is Professor Sebastian. So just to keep going here, we are talking about a quick definition here. There's really not an example for this about increasing and decreasing functions. If you have any questions, certainly ask about that. And then even and odd functions are something that we'll need to have a good grasp on as we come around. So that's what this next function is. Notice that, of course, not every function is even or odd. I mean, most functions are neither. But if a function is even, then if you were to plug in minus x to the function and do some algebra and work it out, you would see that there's no difference between f of minus x and f of x. These kinds of functions are even functions, and what happens with even functions, their graphs are symmetric about the y-axis. So you can see, for example, a very simple even function, probably the most classic example, f of x equals x squared. If we were to plug in minus x, you plug in minus x, f of minus x is quantity minus x squared. So the minus 1 squared becomes positive 1, and you still just have x squared, which is, of course, what f of x was originally. And you can easily see that it's symmetric about the y-axis. The classic example of an odd function is g of x equals x cubed. If we were to plug in minus x into f and do the algebra, you work it out and you come out to see that f of minus x is actually equal to minus f of x. So in this case, when I plug in minus x for x into g of x, we see that g of minus x is quantity minus x cubed. The minus 1 cubed is still minus 1, so it becomes minus x cubed, which is the opposite of g of x, or minus g of x, which is the classic example of an odd function. And here you can see that an odd function is symmetric with respect to the origin. So an even function, symmetric with respect to the y-axis, and odd function, symmetric with respect to the origin.